In this video, we will be solving a numerical problem from the topic a trapezoidal channel. So, this is the question. A trapezoidal channel has side slopes of 3 horizontal to 4 vertical and the slope of its bed is 1 in 2000. Determine the optimum dimensions of the channel if it is to carry water at 0.5 meter cube per second. Take chassis constant as 80. So, the given data are a trapezoidal channel has a side slopes of 3 horizontal to 4 vertical. So, that is n. So, what is n? Usually, we designate the slope as for 1 vertical there is n horizontal. For 1 vertical there is n horizontal. What is the question here? For 3 horizontal to 4 vertical. Okay. That means the tan theta. So, tan theta is equal to usually slope is designated as for 1 vertical there is n horizontal, vertical to horizontal. So, here the tan theta is there is 4 vertical to 3 horizontal. That means tan theta is equal to 4 by 3. Tan theta is equal to 4 by 3. So, what is tan theta? Tan theta is 1 by n. Tan theta is 1 by n. That means n is equal to 3 by 4. That is 0.75. 0.75. So, n is 0.75, 3 by 4. And the slope of its bed is 1 in 2000. So, the slope of this channel bed. So, this is the channel bed, this is the channel. So, this slope is I. So, the slope of the channel bed I is equal to 1 by 2000. Determine the optimum dimensions of the channel if it is to carry water at 0.5 meter cube per second. So, 0.5 meter cube per second, that is discharge. Discharge Q is equal to 0.5 meter cube per second. Take a chassis constant as 80. So, chassis constant C is equal to 80. Okay. So, there is a slight difference in this question. So, earlier we have shown that the best side slope for the channel is theta is equal to 60 degree. That means n is equal to root 3. N is equal to root 3. Sorry, that means tan theta is equal to 60 degree. That means n is equal to root 3. But here n is equal to 0.75. Okay. So, we have to make this channel as the most economical one without changing n is equal to 0.75. Okay. So, the other given data is I is equal to 1 by 2000, theta discharge Q is equal to 0.5 meter cube per second and chassis constant C is equal to 80. So, what are the conditions for the channel to be the most economic one? The first condition was half of top width. Half of top width is equal to length of side slope. So, what was the length of top width? So, the top width is equal to B plus 2ny, where B is the bottom width, y is the depth of flow, B plus 2ny by 2 is equal to side slope, that is y into square root of n square plus 1. So, we are asked to find out the optimum dimensions of the channel if it is to carry water to 0.5 meter cube per second. That means we have to find out a dimension, that means B and Y. Okay. So, let us apply the first condition, half of top width is equal to length of side slope, B plus 2ny by 2 is equal to y into square root of n square plus 1. So, let us substitute n here. So, B plus 2 into 0.75 y by 2 is equal to y into square root of 0.75 square plus 1. So this is b plus 2 into 0.75, that is 1.5. Y is equal to 2y into square root of 0.75 square plus 1. B plus 1.5 into y is equal to 2 into y into the value is 1.25, that is 2 into 1.25, that means 2.5 into y, that means b is equal to 2.5 y minus 1.5 into y, that is y. So b is equal to y. So for this channel with the side slope n is equal to 0.75, the channel becomes most efficient when b is equal to y. So we have to calculate the value of b and y. Also the second condition was hydraulic mean radius. Hydraulic mean radius m is equal to y by 2. M is equal to y by 2. Okay. Now the discharge is given, q is equal to 0.5 meter cube per second. The discharge is nothing but the area into velocity. Discharge q is equal to area into velocity. Here the Chassis constant is given, so we have to use Chassis equation for finding out the velocity. If he gives Manning's coefficient, then we have to go for Manning's equation. Okay, please note that. Okay, q is equal to 0.5 meter cube, that is equal to area into velocity. We know that the area A is equal to top width plus bottom width by 2. So top width is nothing but b plus 2ny plus bottom width b divided by 2 into the height y. So this is the area, that means b plus 2b plus 2ny by 2 into y, that is b plus ny into y. So this is the area, b plus ny into y. So the area A is equal to b plus ny, that means area A is equal to b plus ny into y, but we have already found out b is equal to y. So let us substitute b is equal to y. So y plus ny into y, this is equal to n plus 1 into y square. So area A is equal to n plus 1 into y square. This is equal to value of n is equal to 0.75. So 0.75 plus 1 into y square is equal to 1.75 y square. Okay, this is the value of area. Now velocity v using Chassis equation, velocity v is equal to c into root mi. So this is equal to Chassis constant c as 80 into square root of mi. M is nothing but y by 2 into I is the slope of the channel bed, that is 1 by 1 in 2000. Okay, if you simplify, we will get the answer as 1.264 by raised to 1 by 2. Now discharge q is equal to area into velocity. Discharge is nothing but 0.5. 0.5 is equal to area. Area is 1.75 y square into 1.264 y raised to 1 by 2. This is 1.75 into 1.264 into y raised to 5 by 2. So On solving, we will get to y is equal to 0.551 meter. So this is equal to B. Okay, thank you.